Share
You fork
screen.
it? I did. I forked it.
All right, we're gonna talk about remote access today. Is everybody familiar with remote access? Has anybody SSH'd into another machine before?
I'm familiar with it.
All right, that's what we're gonna do today. You absolutely can.
Create a recursive loop that fries the motherboard of pro.
As long as you guys know each other's IP addresses. All right, so a little bit of, he's already in. A little vocabulary before we get started. So what we're gonna talk about is the ability to use a computer that is, well, use a different computer than the one that you're sitting at. And this is something that I use all the time. So I've got a really nice computer in my office. So when I'm at home and I need something off of that computer, I can remotely access that computer. I can either run code on that computer, or I have files that are stored there. If I forget to copy those to my laptop before I leave, I always have access to them. So when we're talking about remote computers, when we say local, we're talking about the physical machine that you're sitting at. That's your local computer. The remote computer would be the machine that you're going to log into. You need a username, which is the, when you created a username and a password on your Linux install, when you guys created it at the beginning of this semester. If you're going to log into a remote computer, you have to have a user account on that computer. So you need to have a username for that computer. And it doesn't have to be the same as the username that you have on your local machine. So you need to have login credentials, essentially, for the computer that you're going to try to access. If you're trying to access a computer that you don't have login credentials for, Hoffman, that's hacking. Right? So that would be a bad thing to do. You should have access to the computer that you're trying to access. Host is the name of the computer that has the user account that you're going to access. So a remote host would be the computer that has your user account on it that's not the one you're sitting in front of. And then you have a local host, which is the computer that you're actually on. For a login, you need to have a username and a password for the account. If you don't have a password, you're not going to be able to log in. And then just some terminology that gets used when you're trying to use a remote computer. For example, a service is a task that can be provided by the host. A server is a program that sits and listens for things, for connections, and then provides some service. So the most common example that we would know would be a web server. A web server is a computer that has a service that runs on it that says, if I get a connection from somebody that's asking for a web page, create that web page or retrieve that web page and send it back to the browser. The client is the program that communicates with the server. So your web browser would be the client in a web server, web client scenario. We're going to use SSH, which is the secure shell, and there's a server that runs on the remote computer that provides you access to the computer through a secure shell. Yes, Derek.
So how that you need the login access? Would you be able to log into the default admin account that's built into any Windows 10 computer?
No.
That would not be an account that you get.
Well, for one, I mean, maybe, but Windows doesn't have an SSH server, so you can't SSH into it.
Okay.
Usually they have like remote desktop type stuff. Yeah, if there's a default user account on the computer that is the admin account and they haven't changed the password, then yeah, if you knew what its IP address was, you could log into it.
Yeah, because Windows computers come with a built-in admin account that it's. So
yeah, I have no idea. All I know is I can't SSH into. I can't SSH into my Windows computers. Yes, Tyler.
If you have Windows, you can have let's talk about running Linux commands and programs on it. If you do some handful of configurations.
Yeah.
So I assume that
You'd still have to have an SSH server running,
yeah.
which is not going to be running by default. All right. So scatcat.fhsu.edu runs a web server. It turns out that all students get an account created on this computer. So scatcat.fhsu.edu. If I go to that web page, it looks like this. But it turns out that everybody has some space set aside for them that you can access if you know how to access a computer remotely. So this is my space that's set aside. So scatcat.fhsu.edu/tilde, then my TigerTracks username / goes to the web page of that is pointing to the storage that I have set aside. Bless you. What we're going to do is see how we can log into that computer, put some stuff in the correct directory so that it shows up on this web page here. The one thing that you're going to need is your TigerTrax username and ID or password. So this needs to be your TigerTrax username, and then we're going to use the TigerTrax password to log in. So this is what I ran my class website on last semester until we started having all of those failures, and I moved it to another web server. But basically, for every web page that you see, there is a computer somewhere that is listening for these connections and determining what happens, how to respond to this web page request. So it turns out that if you log into the scatcat.fhsu.edu computer, anything you put in the directory called public HTML, which is going to be in your home directory, will be displayed on this web page here. So if you know how to create a website, but you don't want to pay for hosted website, you have a free hosting on the ScatCat computer. So SSH is the command that we're going to use to access the remote computer. SSH stands for Secure Shell, and it's a command that lets you access the shell on a remote computer. The whole purpose of developing our command line Kung Fu is so that we can access remote computers. If the only thing that we have access to is the command line of this remote computer, we could still do a lot of work, right? We know we can write text files from the command line. We could compile LaTeX files from the command line if we need it. So everything that we've done at the terminal translates to accessing remote computers. Now, this remote computer is completely separate from the computer that you have. You are not going to have administrator rights on this computer. You're not going to be able to install whatever packages you want, right? So you're not going to be able to apt-get anything that you want. But the stuff that's available on that computer, you can use. So you're going to need a network connection. Clearly, you need to be connected to the internet, and you need a login. The syntax for logging into a remote computer is the SSH command, your username for the ScatCat computer. This needs to be your TigerTrax username. @ the name of the computer that you're trying to access. And actually, this is the name of the IP address for the computer that you're trying to access. And computers that are set up to have like scatcat.fhsu.edu is actually an alias for an IP address that the interwebs are aware of. So you can use scatcat.fhsu.edu. All right, so let's see how that works.
We can log into a remote computer using the SSH command. SSH is a secure shell for access.
You should just start
Pay attention, please.
Line of a remote computer.
My job's getting easier.
Pretty soon you won't even have to show up.
I won't. I'll just start it and walk out. All right, so here's how I would log in. My username for TigerTrax is CD Clark. My username that I use for every other computer is CC Clark. So I have to type in the username that I want to access the remote computer with in front of that @ sign, and then it's scatcat.fhsu.edu. If the username that is on the remote computer happens to match the one that you're using on your local machine, then you don't, that username part would be optional. But for example, Dinkalittlestar is not going to be the user account on any other machine other than the ones that you've created yourself. So you're going to have to put that little piece there. If everything works, you're going to get, if you haven't logged in before, you're going to get something that asks about a fingerprint. That's fine. If you haven't logged into this machine before, this is expected. The purpose of this is that if you go to log into this machine again at a later date and this thing comes up again, it means that something on the end has changed, on the server side has changed, and that's a possible middleman attack, right? But if you've deleted the known host file or you know why this is showing up, then it's not a problem. So we type in yes, and then you need to type in your password. And you should see something like this.
Is it password for our computer or for like?
It's for the TigerTrax, so it's the remote user account password.
You made the ASCII art.
Yeah, we see it's got a little bit of ASCII art here. ScatCat.
That cat only has 3 legs. I very clearly don't have 3 legs.
Well, I mean, I don't know about you, but.
Oh, is everybody logged in?
Yeah, I actually got in.
All right.
Why is yours like this? Oh my God.
Yeah, the host name for the local machine is Syscat. The IP address is SCATCAT.
We are now logged into a remote computer. The computer located at not FHSU, not FU.
That's the last one.
Thank you.
All right, let's do LS. See what's on this machine. So I've got, this actually used to be before you guys all have mail.fhsu.edu accounts, right? This used to be the mail server. So all of your mail was actually on this computer. And all my old mail, I still have, like if I looked at this sent items, I've got old mail that used to run through this server stored on here. Do a PWD. You can see that it's organized a little bit different than a standard Linux install. It's not, your home directory is not in a directory named home. Your home directory is organized under all of these different users. Some poking around on the machine just to see what the machine looks like. There's a special file in the /proc directory called CPU info that prints out information about the processor of this machine. And so if you type the CPU, or if you cat that file, you can see that this has got a 1.6 gigahertz Intel Xeon processor. It's actually got an 8-core processor. It shows up as 8 processors with the first one labeled 0. All right, so there's all kinds of information about this. So this is more processing power than my laptop usually has. You can also see who else is logged in on the machine. So all of this stuff that we're using was developed before everybody had their own personal computer, right? There was a computer that everybody sat down at a terminal and logged into. And so you could do things like talk to the other users that were logged in. So right now we see that we've got 1, 2, 3, 4, 5, 6, 7 people that are logged in. You guys are all logged in from Fort Hays addresses. All of this type of stuff gets logged, right? So if the person that runs SCATCAT thinks that something's going on, they start looking through the logs, they see that all of us logged into this computer at this time from these IP addresses.
I'm winning.
I'm winning.
Those aren't points. Those are something with the terminal. So it's like a physical terminal something. So the first one to log in was the one who gets PTS 0.
Your last name is Griffin.
Why were you curious about my name?
I just didn't know your last name, so it's throwing me off.
Who's this guy?
I was like, some random dude's just watching this video.
Logging in. We run who again, and there's like Hoffman. Hoffman shows up, but it's actually his username alias, which is who knows what that is.
Yeah.
Hoff-man. Oh no, Hoffman's like super crazy about like privacy, so it'd be like a random string of characters.
John Doe.
Yeah.
John Doe number.
No. It would be like 47 capital F Q lowercase.
I see that you couldn't get Fort Hays to give you the Jedi Master username on the
Well,
student system.
that's actually my third username. They corrupted the first 2. I couldn't access those files. I don't know how they managed that.
All right, so if you don't already have a directory named public_HTML, just go ahead and create that directory.
I wouldn't trust these school servers all that much.
He's just joking.
I got it there twice.
Is what I would say.
Is what I would say if it wasn't Derek. All right. So I'm going to go into this public_HTML directory. And the server is set up so that anything you put in here will be served as a web page. And if you know how to program web pages, then, I mean, I'm not going to teach you how to program a web page, but this is basically, I think it's an Apache server. Anything that's put in here will be served, and it has the PHP module. So if you want to write your web pages in PHP, those will automatically be interpreted here. So I'm just gonna create a file that says hello world. I'm gonna put it in a test.txt file. And now if I go back to my web page, I should see, this is a directory listing of what's in there. This is the public_HTML directory. I can click on this file, open it up, says hello world. I could download that file if I needed. So now this is public, so you don't want to put anything personal on here. But if you needed to get a document from one computer to another, you don't absolutely have to do the email it to yourself trick. You can put it on here, download it from another computer, or you could put stuff on here and let somebody else download it, as long as it's not copyrighted. I have no idea. Not a lot.
Dude, we literally just pulled up the information. Look in there. We have.
Which one?
Oh, these are just the processors. They won't tell you much information.
Yeah, there's just various things. There's various commands that you can. We catted the file at /proc/CPU info.
Wait, when they have 4 cores, do all of them run simultaneously, or do they run different tasks?
They can load different tasks.
Okay.
So there's a special convention that's typically observed with web servers. I don't know if this is standardized or what, but basically all of them do this. If you put a special file named index.html in the directory, whatever's in that is actually going to be loaded whenever the URL that corresponds to this is accessed. So now, if I try to access my just the web page that corresponds to my username, the contents of index.html are displayed. So if you know how to write HTML, you could create a web page. You could put links in that web page and then navigate through like a web page. I mean, that's essentially what I have here. This web page is just HTML that I wrote, and these links just lead to different directories on this web server. So if you this is a different web server. It's hostcat.fhsu.edu. But if you log into that web server, you would see these tarballs and PDFs are stored in certain directories. All of these slides are stored in certain directories. I can log into that, modify that stuff remotely if I need.
When I try to do the echo of the world, it tells me,
What is it?
oh, I put an exclamation mark. Maybe that's the issue.
Okay, so yeah.
Needs to be in quotes if you want to use an exclamation mark, I think.
Yeah, it is. It says, exclamation mark, parenthesis, or quotation mark, event not found.
Delete the exclamation point.
Okay.
Maybe it just doesn't like that.
Yeah, so if we left that index, how would we be able to re-access the link files that are in there? Because it just loads that blank page that says help removed.
That's a brilliant idea.
I mean, that's what
If that's
did
the
to
file-
fix it.
If that's the file that causes the problem, just delete it.
I was just
Correct.
wondering if there's a proper way to like.
No, that's it. I mean,
Okay.
these web servers are just files that are being accessed by the server. So the browser says, hey, I want to know what file is at this position. The web server says, if there's an index.html file, send that back. If not, create an HTML that represents the directory view. So it's as simple as that. So all of the stuff that we know about using the command line can be used to administer your own simple website. I'm going to do a little bit of HTML here. So let me open up this file. This just contains plain text, but I can mark up this plain text if I want. So let's make this a header. So there's a H1 tag. So if I wrap my text in H1 tags, save this, then my website is now going to show hello world in bold.
Oh boy.
Yeah. You laugh, but it all has to start somewhere. If you don't know how to do
Capital
this,
H1 or just lowercase h1?
lowercase h1. So you can also, from these, on these browsers, you can ask it to see like the page source. So let's view the page source here. And I see there's a very simple page source. All right, just got a H1 tag, closed H1 tag. I go to this web page, view the page source, bunch of links. If I go to my If I go to my slideshow page source, a little more complicated. But it's all HTML that's getting sent to the browser, and the browser figures out how to draw it or render it. All right. So, Derek, you can remove this index.html file, and then you'd have the directory view that shows back up. So I'm going to go ahead and do that. So if I do this now, I get the directory view. One thing that you need to pay attention to is some browsers will cache small websites. So if you make a change and it doesn't show up on here, it probably means, like I always have this problem with Chrome. It means that Chrome cached the HTML for that web page and is just loading the cache. It's not getting a new, a new set of HTML page. So if that happens, you just need to clear the cache. Yes?
Just use links and print everything.
W3C is the one I prefer.
W3C.
It has VI key bindings. All right, so now I'm going to go back to my home directory on this machine, and I'm going to exit. I guess I don't have to go back to the home directory to do that. I'm just going to exit the machine. So to log out, you type exit. All right, so my connection was closed. Bless you. So that's the basics of how you log into a remote machine and use that remote machine. Anything that pops up a window like GNU-plot is not going to pop up a window on your machine. It's going to try to pop up a window on the remote machine, and it's going to fail because there are no windows. There is no sort of display server that's available when you log in to the remote machine. So you can't do things like plot something in GNU-plot and have it pop up a window. You could plot something with GNU-plot and have the output sent to a PNG or the dumb terminal. Do you remember the dumb terminal that we saw where it did an ASCII plot? You could plot to the dumb terminal, but you're not going to be able to plot to the X11 terminal.
But if you try to do like I have no of a PNG, it still won't pop in access.
Exactly. So we just logged into a computer that was not sitting in front of us, right? This is like, how neat is that? This picture here is getting old. You guys probably you've probably never even seen the Matrix. But if you look at this is the Matrix scene where they are breaking into the city power grid to shut down all of the power reactors. And if you look at the shell, these are real commands. Nmap is a command. I'll ask Hoffman what that does. It scans the network. Here it's saying that there's an SSH service that's available on this computer, and they're running Linux or Unix. And then right here, they're logging in. So this is the IP address for the computer that they're logging into. They're logging in as the root user, which is the admin user.
If you look at that top one, it's SSH Nuke.
Yeah. So this is their fictional hacking program that cracks the SSH login. Access granted. And up here you can see that this is an Nmap output. Here's a login here. So this is all just the standard. Oh, it looks like they're using edit VI or V1 to edit their nuke script here. So this is all the same stuff that we're learning how to use. Secure copy is a version of copy that allows you to copy files to and from a remote computer. So the copy command won't copy stuff to a remote computer. The SCP command will. It uses SSH. I mean, there's probably no reason to even know that there are other tools besides SSH, but an old popular one was Telnet. Telnet used to transfer all of the information, or still does if you use it. It transfers all the information to and from the computers over a plain text connection, meaning that if somebody were able to listen to it, which none of us here have the capability of doing, but if somebody was listening to it, they could just see everything that went over that connection, like your password. SSH encrypts everything, so when you're sending stuff to and from, it's encrypted. SCP uses SSH, so you can copy files to and from a remote computer over an encrypted session. So let's see how the secure copy command works. This would also be a way for you to get something from one computer to another computer if all you have is an internet connection. Just secure copy it to SCATCAT. You don't even have to put it in the public HTML directory. Just secure copy it to SCATCAT. go to your other computer and secure copy it down from SCATCAT. So I'm just going to put some text into a file. This is testfile.txt.
SCATCAT,
What's that?
or is this in the SCATCAT?
No, this is on my local machine. I'm on my local machine.
Our
now.
local machine.
Oh, I bet you typed the exit command.
Just exit, okay.
They said that earlier.
What do you think we've been doing this whole time, Derek?
I've
Yeah.
been listening.
I just said type exit text at the shell.
Yeah, Derek, what do you think? You guys do that. I'm drawing.
All right, so I got some text into a text file. To secure copy that to the remote computer, there's a couple of things. It's very similar to the copy command. So what do you want to copy? Where do you want to copy it to? But the difference is that you can now give remote locations. So this piece right here is the remote location. So again, I need to put my username at host name. Then I need to put a colon here and a /.
Are you still in your?
Oh, don't even. I pointed it out already. Isn't that still in your remote terminal?
Yeah.
But it says at the top, it still says.
Yeah, it still says it for me too.
Refresh your terminal.
What the? How do you refresh it?
You close
it.
You close it and
cares?
open it again.
Okay.
Yeah, I exited.
Okay.
And I loaded a script that's not on that remote computer. :/.
There's space.
No spaces. So what this is doing is, well, it's telling the username that you want to use, the computer that you want to use. The :/ is to tell it what directory to put it in, and you got to have that. The directory that you're going to put it in is going to be with respect to the home directory. So // is going to be the home directory of the user that you are that you have access to. You're going to have to type in your password, and then you're going to get something that looks like the file was transferred. 100%, 0 kilobytes per second. All right,
That must be a really small file then.
it was. Just some text. All right, so now I'm going to log in to SCATCAT again. So let's log back into our SCATCAT account. Type in our password. I get the ASCII art again every time. I get a nice welcoming, a nice warm
Three-legged
welcome from the tiger. Three-legged tiger.
Get her out.
That last leg does not look like it's coming out of this one.
Yeah. Surely that was automatically generated. Somebody didn't write that by hand. Run ls, and here's that file, testfile.txt. So I've successfully copied it to the remote computer.
Pretty good upload speed of about 3 megs a second.
Nice.
I'm uploading a really, really big file.
Is it just full of some text copied over and over?
Just a bunch of numbers. It takes up pretty close to.
If I cap this file, it's got some text in it. So
many numbers.
I agree that, or I believe that is the file that I uploaded. All right, so let's exit again. So I'm gonna go back to my local machine. That's the exit command. Yeah. My terminal still says syscat. That's not true. Let's see what happens if we secure copy. We try to do a secure copy and we forget to put that colon on there. So I do secure copy, test file, leave off the colon. There's no error, but I noticed that it doesn't print out like the percentage of the file that was copied. And the reason is because it creates a file that's just named cdclark@scatcat.fhsu.edu. So secure copy can be used just like copy. And if you don't put that colon there, it doesn't treat it as a remote URL. So you got to put that colon there for it to copy it to a remote URL. So I'm going to remove that file. That's not what I want to do. Now I'm going to remove this file that I copied up there. So I'm going to get rid of that file. It's gone now. So the test file is gone. If I want to copy something from a remote computer to this computer, I just do the opposite. I give my remote URL for the first argument. I give my local URL for the last argument. I need to give the path with respect to the home directory on that computer. So again, it's just cdclark@scatcat.fhsu. There's a : /testfile.txt. Now there is no file completion, so you can't hit tab to get it to file complete the file name on the remote computer unless you're using Z shell. But you can use globs. So if you knew that it was test something.txt, you could put a test star.txt and it would copy all of those files. I'm gonna have to put in my password here. And I have now downloaded the file. So when we copied it up, that would be considered upload. When we copy it down, that's considered download. Yes, Tyler.
Can you do multiple files at once?
Yes,
Okay.
I believe so.
Okay, because if you don't have a strong internet connection, a bunch of big files somewhere.
Yeah, I would just tar them up and then copy the tarball.
Yeah, I do have a tarball. But you can, I'm trying to put a 10 gigabyte file up there.
So I can also give, if I know how relative, that's probably too big. No, I mean, I think that you're gonna run into your quota. Probably get flagged. We probably got people showing up right now come to find you.
What are all the numbers?
Yeah, there's no way
Well-
there's no way you've got 10 gigabytes worth of
There's
space.
some idiot trying to distribute like pirated DVDs through this service.
Yeah.
And yeah, he got.
Yeah, so don't do that. So I can also give, I don't have to just copy to my home directory. This piece right here is a relative path name with respect to home. So you could copy directly into subdirectories of your home directory. Everything's the exact same as using copy, except for this little piece right here that says this is on a remote computer. So I'm going to copy the test file straight to the public HTML directory. I have to enter my password. If I can now go to my HTML directory, that test file shows up. It has some text in it. But it's not header text, it's plain text. We're gonna find out.
Wait, what?
So this is we just wanted to show this web page again. All right, what's that?
So if you have that index thing still on there, if you delete it, you have to delete it.
Yes, yep. All right, now I'm gonna go to my home directory and I'm gonna copy a directory up to the remote server. So I have a directory called code that contains all the code that I've written for this class. I'm gonna copy that directory up there. So I'm gonna do a secure copy code. I'm just gonna put it in the home directory. I have to enter my password. And I get that code is not a regular file. So just like the regular copy command, I have to tell it to recursively copy directories in order for it to copy a directory for me. So I'm gonna have to give it the TACR option. Unlike the copy command, I can't put TACR at the end. So all the options for the secure copy command have to come before the arguments. So if I forget to put the TACR on there, and then I just go up in the history and I want to put a TACR at the end, that's not going to work. I need to put the TACR at the front. So I'm going to secure copy up to my home directory. I need to put in my password. And it just starts copying files.
Some of these files are just strings of letters.
Those are your Git repository files.
All of those are less than a handful of kilobytes.
Let's see a 23.
Yeah,
All right.
600.
I'm going to log back into ScatCat. I need to put in my password here. And the code directory is now on the remote computer. So if I needed to back up, there's better ways of backing up, but if you absolutely need to make sure you've got a remote copy of something so that in case something catastrophic occurs, it's not totally lost. And so here's all the stuff. We wrote the CL Utils program. I have some miscellaneous code. The GSC program is in there. All right, so let me exit.
How do you clear the cache? Because it's not letting me like load to the new HTML. It's just bringing up the
know.
original one over and
Yep.
over.
Is this Chrome?
Firefox.
Firefox? Yeah, I don't know. I think there's like a, if you do a shift F5 maybe, it clears the cache,
Brought up
not cache.
Weird. It brought up like a command input.
Control F or Control F5? I don't know. Just Google.
Yeah.
Start hitting buttons.
I'll send let me Google that for you, link. I can move so I can delete this local directory, which I already have a copy of. Let me just remove it. Yes, I want to delete it all. Oh, no. There we go. So I would secure copy from the remote server now. Got to put my username in. Code, and again, I can't put the TACR at the end. It's going to complain about it not being a regular file after I put my password in. Thank you. So I got to go all the way to the front here. Oh, and I have to give it the directory I want to copy to. There we go. And now it copies it down. So secure copy, that allows you to copy stuff back and forth.
So I copied the files over, but they're not appearing on the index. Do I need to do a second step after copying the files over? Because they appear by LS, they just don't appear by index.
If you copy it to public.
It's got to be under
Gotta be
the
in the
public underscore HTML directory. That's the one that gets loaded. All right. Who's tired of typing passwords?
This kid.
Yeah. So let's get something set up so that we don't have to type passwords anymore. Now we don't want it to. We don't want to just set the password to nothing. That's not secure. We want to do this in a secure way. So go to your home directory on your local machine. What we're going to do is we're going to set up some SSH keys. This is a standard computer science security measure. If you look at all the directories in your home directory, you may or may not, you probably should, since you've SSH'd, you're going to have a directory named .ssh in your home directory. So it's hidden, only hidden because it's named .ssh. Go into that directory. If we look at what's in that directory, probably everybody just has a file called known hosts. If you cat this, it contains a bunch of what appears to be random numbers. These are, when we logged into SCATCAT the first time and it said that there was some RSA fingerprint and it wanted to know if we were okay with that, it stored that fingerprint in this file. So the next time we log in, it can tell whether or not something has changed. All right, so we're going to create a pair of SSH keys. And we're going to do that using the SSH key tac keygen command. This is going to ask us a couple of questions. The first one is, what do we want to name the file? Just choose the default here, so just press enter. This is going to create a file called ID_RSA. Enter your passphrase. So we don't want to have to enter a passphrase. So if we use these keys and we gave it a password, every time we use the key, we'd have to enter a password. It would not be the password that's on the remote machine. So we could change our password if we wanted, but we don't want to enter a password. So we just enter and press it again. All right, so now we have some SSH keys that allow for a passwordless entry.
Random worker, like a chef code. Is that like a stamp to show who you are?
Yeah, exactly. It's just a little fingerprint.
Snapchat.
Yeah, Snapchat uses the exact same. Well, I don't know if it's the exact same, but it uses the same type of technology. Now, there's a couple of things that show up here. There's an ID_RSA, and then there's one that's .pub. The .pub is the one that it's okay for other people to know. This ID_RSA is not okay for other people to know. This is your private key. So if you're going to communicate with somebody securely, you give them your public key, and then you keep your private key, and you can encrypt and decrypt stuff. So Tyler's working on a project that does similar stuff.
That's great.
So, for example, it is okay for me to print the contents of the public key to the screen here. It would not be okay for me to print the contents of that private key to the screen. Then I'd have to get rid of that key. Yeah.
You stab me.
So what we need to do is we need to copy this public key to the remote computer, which is perfectly fine to do. You can copy that to remote computers. Then we're going to put that public key in a file that tells the remote computer that, hey, if somebody has the private key that corresponds to this public key, they can log in using those keys. So I'm going to use a secure copy to copy this public file to my home directory on the remote machine. I'm going to have to enter my password here. And I have copied it up there. Now I need to log in to that machine so that I can put that file in the right place. So I'm going to SSH into the remote machine.
It's like 2 gigabytes. 2.5.
That's your limit.
That's your limit. It just said this.
Using, so your mailbox where you guys still be using that would say using 2.2 of 2.2 gigabytes.
Yeah.
SSH up. Need to type in my password.
Should probably get rid of that.
You probably should. You're not going to be able to copy anything else up there. All right. I'm now on ScatCat. If I run ls, here is my key. If I look inside there, this is just a very long list of random numbers that corresponds to something that the private key matches, right? So to allow passwordless logins, what I'm going to do is, it's not liking this. Oh, I know what I'm going to do. There we go. I'm going to cat that file and I'm going to append it. So I need to use these two greater than signs, not a single one. I mean, right now a single one would work fine, but if you want to add like if you have another computer that you want to log in from, you need to append to this file that's called authorized keys that is in the .ssh directory. So the remote computer has a .ssh directory as well. You put the public keys for computers that should be allowed to log into this user account without passwords, or using the keys really, because you could attach a password to those, in the authorized keys. So notice that it's in the .ssh subdirectory as well, authorized keys. All right, now to check that it works, just exit using the, which command is it, Dinkle?
Exit, I think.
EXIT, yeah, exit command. Connection is closed. Now you should be able to SSH to the computer without it asking for a password.
Some here don't have
Yeah, mine's
authorized keys.
no such file.
Hey.
Yeah.
Which part? The .ssh?
Yeah, the .ssh authorized.
So that probably means there's no .ssh. So do an ls tac a.
You are correct.
Okay, make that directory and then rerun this.
Make sure.
So if we were to use word to have put a password on those keys when we created them.
That is the password you'd have to use here.
Okay, so then it prompts us for that password, and then but it would check it locally. It wouldn't check it server side.
I have no idea. I've never done that.
That's not gonna exit.
Oh, there it is. Didn't ask me for a password.
Yours is
Yeah.
just like boom, done. Mine's just
I got a
like,
fast connection.
gotcha. Okay, now.
So there's a couple of things that are useful here. One is we don't have to log in with passwords. I can use secure copy without a password now, which means I could write shell scripts that do a secure copy and would not ask the user for a password. Now, you wouldn't want to give that shell script to somebody. This will also only work on this computer. I couldn't like write a shell script that's secure copied up to this machine, give it to somebody else, and then they could run it on their computer because they don't have my private key. So the private key is associated with this local computer, and that's the only one that's going to be allowed to log in without a password. If you used another computer and tried to log in, you'd be asked for a password. I'm going to remove this public key file here. It's no longer needed. And exit the server. So there you go. Now you can log in without passwords.
So what if, like, I have a desktop sitting in my room, if I want to keep that running and be able to access it from my laptop, what would I have to do to set up that?
You need a static IP address is what you have to do. It needs to have an SSH server running, which if you're using like an Ubuntu install or any Linux install, by default, it's probably gonna have an SSH server running. So the only tricky part is the IP address. So I'm gonna create another test file and then I'm gonna copy that up, which I picked the wrong. I mistyped it. So I'm going to copy this up here into the public HTML directory. It copies. Doesn't ask for a password. Now this file contains the text that I just used. Another nice thing about SSH is that if you don't give the SSH command any arguments other than the thing that you want to log into, it will open up a shell and it'll log you into that shell. If you give it another argument, it will run these commands on the remote server. So this is a listing of the stuff on the remote server, which I don't have to use a password for because I set up my SSH keys.
So from this, you can like cat something, right?
Yeah, I think so.
And then run a program or shell script with it.
Public HTML test.txt.
You don't have to put them in the quotes.
I do if there's spaces.
Oh, yeah. Spaces.
And so you want to pipe this through, well, let's just pipe it through head. Yeah, you can. I could also remove that without logging in. So let's just say I want to remove that file now. Go up here, go back, do a refresh, that file's gone. So I don't have to log in, which means I could write a shell script that would run shell code remotely on a machine that I have access to from the machine that I'm trying to run the shell script from. There you go. Next thing on Wednesday, we're gonna see how to set up these SSH keys for with GitHub so that you can push and pull changes from GitHub without typing in your username and password. And then that should do it for the semester. Friday, we have a seminar during this time, so we will not be meeting. Second stage for your project is due